So, starting chapter 3, we are talking first in section 3.1 about measures of center. Now, I would venture a guess that everyone has heard of these before. They may not have heard them called measures of center, but they are, number one, the mean. And when we talk about mean, we're also going to talk about weighted means. Number two, the median. And number three, the mode. So mean, median, mode. These are the backbone of statistics. They're the three things that I think most people think of when they think of statistics. These are the stuff that you need to calculate and know. And then the fourth thing we're going to talk about is choosing an appropriate measure of center. Measure of center. Because not every data set is going to want all three of these or even two of these sometimes. So let's start with means. Our two basic means, the arithmetic mean and the geometric mean. Now we're going to talk about arithmetic mean specifically here. This is the average. This is what everyone thinks of. Mean means average is that old slogan that gets taught to elementary school and high schoolers everywhere. And in statistics, we have two statistically based means for analysis, the sample mean and the population mean. So the sample mean is the average of all data points in the sample, and this is denoted as x bar. So we read this as x bar, and it's x with a bar over it. Very, very clever, I know. And so this is x1 plus x2 plus ... all the way until x sub n, all divided by n, where n is your sample size. And we can shorthand this as the sum of all x sub I over n. X sub I is the ith data point or data value in the sample, and n is our sample size. So that's x bar, that's our sample mean. And then when we're talking about populations, we have population mean, and this is mu. It is a Greek letter. Mathematics loves Greek letters because the ancient Greeks built classical mathematics as we know it. So mu is this symbol. It looks like an M with a long leg on the right or on the left and a little bit of a swirl, a curl on the right. So that's mu. And this is x1 plus x2 plus ... all the way down to x sub capital N all over capital N, or shorthanded as x sub I over capital N. And again, x sub I is the ith data value or data point in our population now, and capital N is the population size. So an important note that we want to make here is that sample is less than population, and means are used for quantitative data, not qualitative data. So if you have a lot of values, a mean is a great measure of center to use, and it gets used a lot. The average score, the average this, the average that. But your sample size or your sample mean should be less than your population size or your population mean generally. So when we're talking about means, we're doing a division, we're adding things up. If you've ever calculated an average before, you know that almost always results in some sort of decimal. So we need to talk about rounding rules. So the first and most important rounding rule is that you match, always match, decimals to the biggest decimal in the data set. Except for our second rule, which is for means, use one more decimal place than appears in the data set. So if you're ever wondering what should I round to, if you're just rounding a value, match the number of decimals to the highest or to the longest decimal place that you see in your data. If you are calculating a mean, go one more than that. So we're going to do an example on the next page here. We'll talk about those decimal places. So here we have some evening populations for Math 119 classes, evening, afternoon, and morning populations, so class sizes for Math 119. But we're going to calculate both sample mean and population mean. So, and we'll also talk about how to do this on the calculator here. Make it easy, I'll set that off to the side. So we have three statistics. All of them are going to be X bars for the evening, X bar for the afternoon, and X bar for the mornings. And then once we have those, we will need mu, which will encompass everything. So the X bar for the evening is the sum of all the data points divided by the sample size. And in this case, it's the sum of all the data points divided by 6. And so we're just adding up all 6 of these data points, 25 plus 40 plus 30. So I'm just going to do that on the calculator real quick. And when we do that, it's 176 over 6. And now this does not go in evenly, so we're deciding our decimal. We approximate it. Since there are no decimals, we're going to include one decimal. So the average is 28.7, but context is king in statistics. These are people. These are class sizes. So this is students that are in those classes. You can't have 0.7 of a student, so we would say 29 people on average, because they're people. Now, if this was dollars or something that can be fractionalized, can be split into tinier pieces, then yeah, we can use decimals. So let's talk about how we do this on the calculator now for the X bar for the afternoon, the sample mean for the afternoon. It's the same formula, the sum of all data points divided by n. But on the calculator, if we go to our stat, just like we did before when we go to edit, we have this list features here, list 1, list 2, list 3. I'm just going to enter the afternoon data, 44, 41, 30, 26, 24, and 28, and then I need to delete. Now, so this is what we want, just our data points, nothing else. We don't need anything in the other lists. The other lists just allow you to do other things. And then we're going to go back to stat. Actually, we're going to quit second mode to quit. We're going to go back to stat, and I'm going to go over to the calc, and we're just going to do the one var stat. So var is variable. So just one variable stats, enter. Now I only have one list, so this is the only thing it is. And you can see the very first thing it tells us right here is X bar. So X bar is 32.1666667. So we need to only go to one decimal place. So 32, covered it up, 32.2 is our X bar for the afternoons. And again, you can't have 0.2, so we round up to 33 people, because you can't have 0.2 of a person. Now we're going to talk more about this screen in a little while in the coming sections, but for now, that's how you can do a mean relatively quickly. So again, that's stat, edit, and then you enter your list in list 1, and then stat, calc, one var stats. So that's a little key you can use. So for X bar, for the mornings, again, it's the sum of all the data over n. And this, using my calculator again, I have 34.2 rounded up to 35 people. And then for the population mean, we are taking all of them. So there's a shortcut that we can do, two shortcuts. First is we could go back to the calculator, and we could go back to the edit, and in the list we can enter in all the data values we have if we so desired. The other shortcut is you've already added up a lot of the data. So I have 176 plus 193 was the total for the afternoons, plus 205 was the total for the mornings, and then there are 18 total data points. And so this is 574 over 18, or 31.9, which gets rounded up to 32 people. So let's square that off there. So these are our means. And again, context is king. So we can look at these means and we can see that the total average is 32 people in a stats class in 119. That's pretty accurate, I would say. And most students are taking it in the morning, slightly fewer are taking it in the afternoons, and even less are taking it in the evenings. And traditionally this makes sense for math enrollments. Most people like to take their classes in the morning. Less people take it in the evenings in general. So it makes sense that our averages are smaller. Now that doesn't mean that, for instance, we have one of the highest enrolled courses is in the evenings, and that is pulling that average up slightly compared to the rest of these. But similarly, that 19 here is pulling that average back down to even it out. So we have some other problems we can do here. So just calculating means is not the only thing we can do with it. So in this example, we have 5 ebooks are downloaded, and on average, each book costs $3.64, and the last 4 books cost exactly $4.01. How much did the first book cost? So we can take our knowledge of means. Now I'm going to use mu here, but it really doesn't matter whether you use mu or x bar. And we know that mu is book 1 plus the cost of book 2 plus book 3 plus book 4 plus book 5. And there are 5 total, and we know that this has to equal 364. That's the average. We also know that the first 4, books 1 through 4, cost 401. So 4.01, there are 4 of them, plus whatever book 5 costs, divided by 5 equals 364. So we're really just solving for book 5's cost. So multiplying by 5 on both sides gives us 16.04. We're just simplifying 4 times 4.01, plus book 5 equals 18.2 is what 3.64 times 5 is. And then book 5 equals 216, and that's dollars. So the point of this example is really to showcase how different outliers in your data can manipulate that mean, because through the first 4 books the average is exactly 4.01 because they all cost the same, but we introduce one cheaper book and all of a sudden our average drops to under $4. So when you have a really big outlier, that average can drop incredibly fast. So for instance, let's say that our average, or let's say this last book was 50 cents. So I'm going to move to my calculator to do this. So I have 4 times 4.01. Those were the first 4, plus, oops, that reminds me, this is 1604. And then we add just 50 cents. And now divide by 5, and all of a sudden our average looks like only $3.31. Much, much lower. But that's not indicative of what most of the books cost. So this is the problem with means, is outliers can really stretch that data. So to help with that, there's another kind of mean when you have categories of things that are weighted differently. And this is exactly what your grades are based on. So all of your grades and all of your classes are weighted means. So the weighted mean is the mean of a data set, which in which each value does not hold the same relative importance. So for example, your exams. Your exams in this class are worth much more than, say, your quizzes. Because the exams are harder than the quizzes, they take more intellectual ability to get through because you're timed on them, whereas your quizzes are, you have a longer span of time to finish them, so it makes sense that they should be worth more in the overall scheme of your grade. So our weighted mean, x bar, for a sample, is the sum of your data point times its weight, all divided by the sum of all the weights. So x sub I is the ith data value, w sub I is the weight of that value, and we can calculate a population weighted mean as well, and it's denoted as mu, as well as this is denoted as x bar. So you're already starting to see this. I talked about this in a previous section. Abusive notation, reusing symbols. X bar is mean, it's also weighted mean for a sample. Mu is mean, it's also weighted mean for a population. So you always have to make sure you understand the context that you're working in. So let's calculate a weighted mean. So our class weights, we're going to do it with our stuff. Our class weights are exams 45%, quizzes 5%, homework 20%, Canvas participation 5%, final exam 25%. So let's say you have the following category scores. So not that these are your scores on any particular test or quiz, but overall, this is what you've scored out of 100 in those particular categories. So you've done well in your quizzes, 92. You do almost all your homework, 94% of that. Your Canvas participation is not great. You're not doing much. You're at 22%. You did okay on the final. You got a 60%. And your test you did fine on. You got 78. You're almost at a B. So our formula, x bar equals the sum of all x sub I times w sub I over the sum of all your weights, w sub I. So it's a summation, so we're doing a big addition problem, but we take the first weight times its category score, 78, times, now we don't do 45%, it's always times the decimal, 0.45. Then it's going to be plus 92 times 0.05, then plus 94 times 0.2, and then I ran out of space, so I'm going to continue down here, plus 22 times 0.05, plus 60 times 0.25, and this is all divided by 0.45 plus 0.05 plus 0.2 plus 0.05 plus 0.25, and so altogether now 78 times 0.45 is 35.1 plus 4.6 plus 18.8 plus 1.1 plus 15, all divided by 1. And so this gives us a total of 74.6. And so this would be your final grade if you got these category scores. So as a little practice here, you can calculate a grade using our weights that you would like. And you can do this the same way we did before. So you know what you want to do. Assign yourself a category score. If you want to average a B and 80% on the test, that's what you do. If you want to average an A and 90% on quizzes, 100% of your homework you plan to do, and you're going to do all of the Canvas participation, but you understand that final exams stress you out, so you're going to shoot for just passing the final, you can see what those grades are. And so you should try that out. So the median, I don't know why it has an extra box here, is the next measure of center that we're going to look at. So the median, this is the middle. Oops, middle of an ordered array. Very important that it's ordered. So let's find a couple medians. So it says find the median of the following data. We have to order it, which for large data sets can suck. So in order, this is 1, 2, 3, 4, 4, 5, 6, 7, 7, 8, 8, 8, 9, 9, 9. And then you just cross them off starting at the left and the right. One here, 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 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One more. Right? And so our median then is 7. Yeah, because I didn't cross that 8 off. I knew I was losing my mind. So this is our median here. It's the direct middle. So in the next example, find the median of this data. Median of this data, we reorder 1, 2, 3, 4, 4, 4, 7, 8, 9, 9. We do the same thing. 1 here, 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 1 here. So now we have 2. The curly brace died there a little bit. So we have 2 data points here, 4 and 4. Now, because it's 4 and 4, you can probably guess what it is. But whenever you have 2, you get their average. 4 plus 4 equals divided by 2, so 8 over 2. And our average is 4, which you could have guessed our average. Our median is 4, which you could have guessed because if both numbers are the same, then that should be the middle. Now, it matters that you know to do this when they're not both the same. So we will pause this lecture here, and we'll pick back up in the next video, finishing up section 2.1.